Assalamualaikum. Welcome to the class for ECM 346 for building services. So for this video, we are going to cover subtopic of 1.3, which is electrical machine. For this subtopic 1.3, we are going to cover CO1 and also PO1. And this slide show you the outline of the subtopic. So we are going to look at generator, the theory of generator, basic components in generator, and then we will continue with alternating current AC, and then we will proceed to direct current DC. After that, we are going to look at other component in electrical machine, which is alternator, dynamo, and also rectifier. Right, so for lesson outcome, there are 4 lesson outcomes. The first one is describe the principle of electric generation. Number 2 is explain the basic operation of electrical machine. Number 3, differentiate the alternating current and direct current. And the last one is to differentiate between direct current and alternate current motor. Right, so for the first one, for the generator, so we look at the definition of generator. So what is generator? So basically generator is a machine that can generate electricity from mechanical energy. So you should take note that energy cannot be created, but energy can be changed in terms of the form. So electrical is generated from the mechanical energy. So for types of generator, we will have 2 types. The first one is direct current generator, and the second one is alternate current generator. Okay, for the components in a generator, the first one, the main component is armature, or also known as coil, or sometimes it is also called as winding. So armature is made of conductor, normally copper, and is where a current is induced by magnetic induction during movement of magnet. Okay, and other than armature, the other main component of generator is stator and rotor. So if you look at the diagram here, at the outer side, we will have the stator. So the stator basically is static, whereby it will fix at the position. And at the middle, you will have your rotor. So the rotor will be rotate in order for us to generate electricity from the generator. So if you look at the figure here, the rotor is attached to a shaft, and this shaft is connected to the turbine. Okay, so this is the human here. So look at the size of generator, it's quite huge. So this is for hydroelectric turbine. The turbine will be rotated by the flow of the water. So when the turbine is rotated, it will rotate the shaft, and at the same time the rotor will also be rotated. So once the rotor is rotated, and then the electricity will be generated. So here is the basic diagram for a generator. So here the 2 is the stator. So the stator here is made from the magnet. So if you can see here, the magnet will have a different pole, right? So the first one, the pole is south, another one will be the north. So in between of this magnet, there will be magnetic flux. And then at the middle, you have the rotor. So in this case, the rotor is made by the coil. So the rotor is attached to the turbine. So the turbine will be rotated. For example, if in hydroelectric power plant, it will be rotated by the flow of water. So once the turbine is rotated, it will rotate the rotor inside of the generator. So once the rotor is rotated, the coil here will cut the magnetic flux that exists in between of these two magnets, and then it will produce, or it will generate electricity. So here you can see example of generator. So here is the stator. It will be fixed in that position, and at the middle you will have the rotor. So this rotor will be rotated once the turbine is rotated. So this figure show a figure for the stator for a generator. So the size is quite huge, because this generator can generate up to 660 megawatt of electricity. Okay, then we look at the basic principles on how a simple generator works. So in order for us to generate electricity here, first we must have a magnetic flux. So as you can see in previous diagram, we need to have a two magnet, one with south pole, one with north pole. So in between of the magnet, there will be a magnetic flux. And then, of course, in a generator, we will have to have a rotor. And in the previous diagram, the rotor is made from the copper wire or copper coil. So the third element that must exist in order for us to generate electricity is the motion. So normally for a generator, the rotor must be rotated. So once the rotor is rotated, and then the copper wire will cut the magnetic flux, we will generate the electricity for the usage of our house, for example. Okay, here this figure shows the basic diagram of generator. So the red color is a magnet with the north pole. The blue color is magnet with south pole. So in between this magnet, there must be a magnetic flux. Okay, so at the middle here, there will be a rotor. So for this case, it's made from a coil of wire. So normally the wire is made from copper. So this rotor normally will be attached to the turbine. So once the turbine rotated, this rotor will also rotated, and this rotor that made from coil wire will cut the magnetic flux that exists in this generator. So once the coil wire cut the magnetic flux, the electricity will be induced. So the voltage of electricity produced is called as induced electromotive force, EMF. So there are three ways for us to increase the voltage produced by a generator. The first one is by using a stronger of the magnetic field. So in order to have a stronger magnetic field, we must have to use a huge magnet in the generator, right? So that's why if you look at the size of generator previously, the size is very huge because it puts a very huge size of magnet. Number two is how we can increase the voltage produced by generator is by increasing the speed of the rotation of the rotor. So for simple example, let's say you have a bicycle that have the lamp. So normally the lamp is light up by a dynamo that attached to the bicycle. So for a simple example, if you cycle your bicycle slowly, the brightness of the lamp that you produce is less, right? But if you cycle your bicycle very fast, you can notice that the brightness of the lamp is brighter. Okay, so in order for us to generate a higher voltage, we can increase the speed of the rotation of the rotor inside of the generator. And number three, in order for us to increase the voltage, we can increase the number of loops of wire that cut the magnetic field. Okay, so in previous example here, this is the loop of wire that made the rotor. So if you want to increase the voltage, you can increase the loop or the number of loop inside of the rotor so that you can produce a higher voltage inside of your generator. Okay, so here there are two methods of connection between the coil and the external circuit, so which are by using slip ring. So when you are using slip ring, your generator will be produce alternate current. Another one, you can use split ring or also called as commutator. So if you use split ring, your generator will produce direct current. Right, so first we look at the DC or direct current. So direct current flows in one direction. So meaning that your electrical will be flow in only one direction. So direct current can be generated by various source. For example, is your dry cell here. So you have your eveready or energizer with the size of AA. The second one is wet cell. So this battery normally we use inside of a car. Another one is dynamo, the one that you use at your bicycle. And the third one is from the photovoltaic cell. So for your information, UiTM Pasir Gudang are going to have a solar farm behind of the college, Salsabila and Firdaus. So for the solar farm, it will use this photovoltaic cell and it will convert the sunlight directly to the DC current. Right, so to generate the direct current, your generator must use split ring or commutator. So split ring and commutator is the same thing. Okay, so when your generator use this device, it will produce DC current. All right, so this is example of DC generator whereby your generator will generate direct current for electricity. So it will have the same element here. The first one, it will have the magnet with the different pole, north and south. And at the rotor, it will have the coil of copper wire. So this one indicate the split ring. Okay, so why it is called a split ring? If you look here, it is like a ring, one ring, and then it is split into two half ring. So that's why the name is split ring. So when you are using this device in your generator, so basically your generator will produce DC current for the electricity. So this is example of split ring. Okay, so the explanation is here. Right, so this is the split ring. One ring split by two half ring. Okay, so if you use split ring, it will produce a DC current whereby it will have a fixed pole for positive and a fixed pole for negative. So the current will be flow in one direction only. Okay, so this is explanation for your DC current generator. Okay, next we look at the advantage of direct current. The first one is the power generation can be from a large generator to a portable generator depending on the power demand or usage. And then DC current can be stored for future use in a battery. Okay, so if you have excessive DC current, basically you can store the current inside a battery. And then the last one is the current is more stable and less fluctuation because it is flow in one direction. Okay, then the disadvantage of direct current. The voltage of DC is unable to be changed into different range of voltage. So basically this is the main disadvantage of direct current in terms of voltage. So you cannot regulate the value of voltage for your DC current. And then DC current is very dangerous for public utilization if high voltage. Okay. Okay, next we look at the alternate current, AC. So alternate current is electric current that flow for an interval of time in one direction and then in the opposite direction. So meaning that alternate current will flow in both direction alternately. Okay, so this is example of alternate current. So sometimes it will be positive, sometimes it will be negative. So how to generate AC current? So your generator must use a device called as slip ring. So different with the DC current. For DC current you use split ring, but for AC current you must use slip ring. Okay, so this is your generator. So look here, you have this ring. So for AC generator you must have two ring. So this device is called as slip ring. Alright, so when you slip ring, the electricity that generated in the generator will be AC current, whereby it will flow in both direction. Right, so as you can see here, there will be one ring and another ring. So they are together two rings. Okay, so this is the explanation for the AC current. Right. So this is your rotor that made from the coil. So once you rotate your rotor, electricity will be induced. So it can light up the lamp here. Alright, so what is the advantage of alternate current? So this is the main advantage. The voltage could be lowered or raised economically by using a transformer. This will reduce losses of electrical power. So this is the main reason why many countries generate AC current for electricity supply. So for Malaysia, we'll also use AC current. So TMB will generate AC current to supply to the houses, factory, and etc. So the reason is because AC current can be regulated in terms of voltage, whereby the value of voltage can be increased or it also can be decreased. Okay, so the voltage can be increased for generation and also transmission. So for example, in Malaysia, basically the power plant located far away from the user. So in order to transmit electricity, we need to increase the voltage to reduce the losses of electrical power. And then once it reach the user, TMB will reduce back the value of voltage for the safety, for the safe utilization for the user. Okay, next disadvantage of alternate current. So the current will create a back EMF due to the generated magnetic flux that cut the neutral wire. So this will affect the power supply in a circuit. And then another one, the current is not stable and it tend to fluctuate with time. Okay, so we have covered on AC current and also DC current. So next, we are going to know how to change let's say from AC current to DC current, can be can the AC current be changed to the DC? The answer is yes. So how to convert from AC to DC? We can use this device. It is called as rectifier. All right. So why we need to convert from AC to DC? Okay, because normally we have handphone charger. Okay, so our handphone has a battery. So remember, battery is direct current. In order for you to charge your battery, you must have a direct current. But for Malaysia, TMB supply our homes with AC current. So you cannot charge your handphone with AC current. That's why you need to change from AC to DC. So inside of your charger, basically there will be this device called as rectifier to change from AC to DC. And after you have a DC current, then only you can charge your handphone. Okay, next, how to change DC to AC. So in order for us to change from DC to AC, we need to have this device, and this device is known as inverter. So why we want to change from DC to AC? Okay, for example, UiTM Pasir Gudang is having a solar farm beside of our college. So remember that the photovoltaic cell will generate DC current from the sunlight. So normally the current that generated in the solar farm will be sell to the TMB. And remember that TMB is having a AC current. Our solar farm is having a DC current. So we cannot sell directly to the TMB. But before we can sell, we need to change from DC into AC. So at our solar farm, we must have this inverter to convert from DC to AC. And after we convert from DC to AC, then only we can sell to the TMB. Okay, so that's all for this lecture for electrical machine. So thank you for listening. Hope you understand this information in this slide. Thank you very much.